Today we're going to be doing paper chromatography. Paper chromatography just involves the process of a substance moving through the paper. As it moves through the paper, because of just different adhesive forces, you get some things that will migrate faster than others, and some will stay behind, some will move ahead. So you get the separation of things. It was originally used by a Russian chemist, Sweet, who used it to separate pigments in plant material like chlorophyll, etc. And nowadays it's used for a variety of things. It's extremely popular in organic chemistry where they use gas chromatography. So once you advance to organic, you will get a chance to practice that. So the first thing though you need to understand is what is an RF value. Some people refer to our RF value as a rate of flow, and so we'll just keep it at that. But again, remember, when things move through the paper, because of the density of the paper, things will move at different rates and eventually separate from each other. The same is true when you're doing gases. Because of the difference in molecular weight, they will separate on that basis. Okay, so now I'm just going to talk a little bit about how you calculate RF value on a paper chromatogram. Now, if you look, I've drawn out a chromatogram and I've labeled everything. Now, the baseline is where I started. In other words, this is where I put my sample originally, and when I put my sample in a developing solution, the developing solution climbs up the chromatogram, and as you'll notice, it pulled this, whatever this is, it pulled it apart like that. So when I want to measure the RF value, I find the center of my color. I want the average, so that's why I picked the center, and that was approximately 4.7 centimeters. This is my solvent front. This is how far the liquid moved up the chromatogram and stopped when I took it out right here. So that's my solvent front. This was my baseline. That was 11.5 centimeters. I started at 0 and so forth. So to calculate the RF value, I take the center value, center of my dye, divided by the solvent front, and then I get a value, in this case of 0.41. No RF value can exceed 1. If it does, you've done something wrong. It cannot exceed 1. In the interim, I got my chromatography paper. This is for the food dyes. And I got red, I got green, yellow, blue, and 2 unknowns. Okay, so this is my chromatogram. So I have those. So I have to put my samples on the chromatogram. And if you'll notice at the bottom, I put a line up off the bottom, because when you develop a chromatogram, you have to roll it into a cylinder, place it in your beaker, and if you notice, I do not want my liquid up to that line. If my liquid touches that line, that means the samples will go into the liquid and not up the chromatogram. So I have to know approximately where I want that to be, so I put the line on it. Now you always use pencil to do the line. If I had used ink, the problem would have been the ink would have developed and would have spread with the whole chromatogram, and so it would have been just an utter mess. So you have to use pencil. Okay, so now I'm going to take and put a sample on each one of these, and these numbers correspond to what's in your lab book. So red is 1, so I'm going to put some red on. And occasionally you will find that through the use, students are careless, and sometimes samples are cross-contaminated, so you might get more than what you want or get what you don't want. And we try to prevent that, but it's not very easy. You don't need a lot of sample, but you do have to have your sample. And again, if you forget the numbers, you can get them from the book. I probably should use both ends of my toothpicks, but I don't want colored fingers right now. This is unknown A. Now unknown A will contain one of these four, or a mixture of those four. That we know, and you're going to determine which ones they are. Oops, that's a pretty big one. That's probably going to be messy, very messy. Okay, so now my chromatogram is ready. So if I put it in the beaker, I know when I add my developing solution, which is 2.2% sodium chloride. Mind you, your blood has more sodium chloride in it than this does, so it's perfectly safe. So I want my liquid to come up to about there, so I don't want to add too much liquid. So I want my liquid to come up to about there, because I don't want it touching the line. Okay, so I'm going to add my mixture, or my sodium chloride actually. Okay. Now that I've stapled it together, notice I left a little crease because I don't want them overlapping. So this should be ready, and I can just put it right into my liquid, my developing solution. So I'll put it in there. And if you notice the liquid is below the lines, I don't want to tilt it because it will shift it. And then I'm going to put a watch glass over. The watch glass is sort of to create an equilibrium in the atmosphere in there and let it develop.